Alright, for section 12.2 day 2, we'll take a look at a couple more limits. So finding the limit as x approaches 2 of that particular function. This is one in class that we said that's probably a good idea that you identify what this looks like or know what this looks like, and I'll show you again if you don't remember. Finding the limit as x approaches 1 from the left is what that little negative symbol stands for, of f of x if this is my function. And then two problems that are called difference quotients, or finding the limit as h approaches 0 of this particular function, or of that formula for this function. And then same thing, finding the limit as h approaches 0 of this formula for this function. Again, it's called the difference quotient, which is something that we'll work on in section 3 as well. Alright, so going back to the first one, finding the limit as x approaches 2 of this function. Of course, if you can plug 2 in, plug it in, and of course you can't, because it's going to make the denominator 0. And this is one of the functions I said that you should just memorize. It's one that if you see the exact same thing in the numerator in absolute values as you see in the denominator, that means the function is one of these things. And all you need to do is figure out where this starts and then kind of what the y value would be for both of those. So I don't have to graph it, but let's say I want to graph this. I know it's going to look something like this, and where this number is whatever you get when you set the denominator, or I guess the numerator for that matter, equal to 0, and it's 2. So it's right here where the function is going to be going to the right and then to the left. So all I need to do is figure out what number would I get for the y values. Notice that I'm going to get the same y value regardless of what I plug in if it's to the right of that number, and the same y value if I plug in something to the left of that number. So think of a number to the right of 2, like 3 for example. If you plug in 3, it's 3 minus 2, which is 1, absolute value, that's still 1, divided by 3 minus 2, which is 1, you get 1. Plug in 4, you're going to get 2 over 2. Plug in anything, you're going to eventually get 1. So at the point 2, 1, you're going to have an open circle because I can't actually plug 2 in, and then I'm always going to have a y value of 1. And if I plug anything to the left of it, let's say 1 in, for example, that would give me negative 1 in the numerator. Absolute value of that would give me positive 1. That would give me negative 1 in the denominator. I'm always going to get negative 1. So this is what my graph would look like. And like I said, it's just a function that I would identify what it looks like just by sight. So when I see it, again, I notice these are exactly the same. One of them is in absolute values. If I set the denominator or numerator for that matter equal to 0, I'm going to get 2. That means that at x equals 2, that's where those open circles should be. And then basically look in front of this, or if this is in parentheses, whatever that ratio is, that's going to be the y value, both positive and negative. So it's implied 1, so it's 1 and negative 1. And so I know what the function looks like. And now if I'm asked to find the limit as x approaches 2, well, from the left side it approaches negative 1. From the right side it approaches positive 1. So the limit as x approaches 2, I would say, does not exist, because it doesn't approach the same thing from both sides. Now if I had asked you to find the limit as x approaches 2 from the right of that function, then it exists, because I only have to worry about one side. This would be the right side, and it's approaching 1. So you just have to be careful on what it is they're asking for. This one is asking for the overall limit, so I would say it doesn't exist. Alright, down to the next one. Find the limit as x approaches 1 from the left is what that stands for, of this function. Now, of course, this is one of these piecewise functions, but if you remember, I don't have to graph it. It wants to know where x is equal to, or is approaching 1. If 1 is one of these endpoints, which it almost always is, then I have to look at the two values here where I have 1. So since it is an endpoint, it's one of these two equations that I should be focused on. If this wasn't an endpoint, let's say for example this said as x approached 2. All I have to do is ask myself, since it's not an endpoint, where does 2 fit? It fits in this inequality, so you simply plug 2 in, that's your answer. Alright, so if you get something that's not on the endpoint, that actually makes it really easy. Now I want to know what's happening from 1 on the left side. Ask yourself, is that the left side of 1, or is that the left side of 1? X being less than 1, or x being greater than 1. This represents x on the left side. It doesn't matter if it's equal to or not. I know that one's equal to. Doesn't matter. All that means is you're going to have an open circle. It's still going to approach it. Since this is the side that's representing the left, all you have to do is plug 1 into that equation. And if you do that, you're going to get 3. Now if they had asked you what's the limit as x approached 1 of f of x. So now it wants the overall limit from both the right and the left. Then you would have to plug 1 in here. You would also have to plug 1 into the bottom equation to make sure that they get the same answer. And you notice they actually do. So the limit for this would also be 3. Which means obviously from the right it's 3. So just be careful if it's an overall limit, meaning you don't see anything in the exponent, or whether it's to the left or to the right. But again, make sure that you're okay with identifying how I know that that is on the left side and why I only have to plug 1 in there. Alright, on to the last two, the difference quotients ones, and these are like the last couple that you have in the homework. It's going to ask you to make a substitution. So basically I need to follow this through. And remember what f of something stands for. Like if I asked you to find f of 3, what does that stand for? That stands for plugging 3 in for that x value. So when I ask you to find what is f of x plus h, it wants you to take x plus h and substitute it in for that x. So I'm going to have the limit as h approaches 0 of f of x plus h. So now put an x plus h in here. So it's x plus h minus 2. That's all that happens, is that all of your x's here change to x plus h. That takes care of this part of it. I now have to say minus f of x, which is really just the original function, so minus the square root of x minus 2, and then it's all over h. So take a moment and make sure that you can do this. Here's your original problem. Make sure that you can get this set up. Just writing down the limit, f of x plus h, meaning plug x plus h in wherever you see an x. So it just simply changed that x to x plus h, minus the original function, which is that one, and then over h. And then from there, you're really just doing a limit like we did yesterday when we were doing these algebraically. I can't plug 0 in here. It would cause it to be undefined. I notice I have a radical in the numerator, so I'm going to rationalize the numerator. So I'm going to take the conjugate of the numerator, which is x plus h minus 2 plus the square root of x minus 2. All over, same thing. It's x plus h minus 2 plus square root of x minus 2. Again, the reason I can do that is that's just a fancy way of multiplying by 1. You do want to multiply out the numerator. Do not multiply out the denominator. Remember what your goal is when you're doing this. Your goal is algebraically to get rid of that h. So somehow I've got to get that h to cancel. So in multiplying out the numerator, these two are exactly the same radicals. So it's going to give me x plus h minus 2 minus the quantity x minus 2. So make sure that you're subtracting that quantity. All over h times the square root of x plus h minus 2 plus the square root of x minus 2. Alright, and now if I simplify a little bit in the numerator, I can see that I have x, I have minus x, they cancel. I have a negative 2, that would become a positive 2, they cancel. I'm looking at the limit as h approaches 0 of h divided by h times a quantity. And because that h is being multiplied by a quantity, I am allowed to cancel it. So those cancel, and that's exactly what I wanted. I wanted that h to cancel. So now I am looking at the limit as h approaches 0 of an implied 1 divided by that quantity. Square root of x plus h minus 2 plus the square root of x minus 2. And now, like I said, that this h is gone. Now, however many h's are left, I should be able to plug 0 in, and I shouldn't have an undefined problem. So, if I plug 0 in, notice that I'm not going to write the limit as h approaches 0 now because I'm physically plugging 0 in. I'm going to end up with 1 divided by, if that's a 0, this is just going to give me the square root of x minus 2 plus square root of x minus 2, or that's going to give me 2 square roots of x minus 2. And for right now, you can leave it like this. If you said that you wanted to rationalize it, so you multiply both numerator and denominator by the square root of x minus 2, typically our book doesn't do that when we're dealing with, no. If it was just a number like 2 in there, then they would do it. If it's a function in there, then they typically don't do it. But if you do give that for an answer, it's fine. It's right. There's nothing wrong with it. Or you'll see when you get to calculus, what they'll most likely do with this is they might write this like this. They might say it's 1/2 and then the quantity x minus 2 to the negative 1/2. If I took anything in the denominator and moved it to the numerator or vice versa, remember I take the exponent and I switch the sign, that would make it negative. And then anytime you have a square root, that's like saying it's to the 1/2 power. That's more than likely what you'll do next year. You don't need to do that this year. This would be just fine. Or if you wanted to give me this, that would be okay. But that's what you'll get used to doing next year. Alright, same thing for this one. I have two x's, so now when I plug x plus h in, I have to do it twice. So I'm going to have the limit as h approaches 0 of, here's the f of x plus h. I'm going to put a bracket around it to kind of separate it from the other stuff. It's 4 minus 2 times x, but x gets replaced with x plus h, minus x squared, but x gets replaced with x plus h, so it's x plus h squared. So notice that I basically copied down that function, but I replaced x with x plus h. That is this part of it. I still have minus f of x, which is the original function. So minus, put parentheses or bracket or whatever you want, but make sure you distribute that negative. It's 4 minus 2x minus x squared. And now it's all over h. And now your job becomes simplifying that numerator as far as you can. Again, the major goal is you want that h to cancel. So if we do everything correctly, that h eventually will cancel. So I'm going to simplify the numerator. It's going to be 4 minus, distribute the 2, so minus 2x minus 2h, careful with your signs, minus, and then make sure that you FOIL this. So this is a quantity, it's x squared plus 2xh, if I do the insides and outsides, plus h squared. And I will need to distribute that negative. I'm going to go ahead and distribute the negative here to get negative 4, positive 2x, positive x squared, and that's all over h. Alright, now, you probably should get some things to cancel in the numerator, and so if I look at my numerator, I've got a positive 4, a negative 4, they cancel. I've got a negative 2x, positive 2x, they cancel. I have a, if I distribute, negative x squared, positive x squared, they cancel. So what am I left with in the numerator? I now have the limit as h approaches 0 of, my numerator I still have, don't forget that negative, it's negative 2h from this term. Distribute the negative, it gives me negative 2xh. Distribute the negative gives me negative h squared over h. And when you look at it, this should happen if you do this correctly. All the terms that are left in the numerator have h in common. Why would that be good? Because I can factor an h out and I can cancel it with that one. So now that's what I'm going to do. So I have the limit as h approaches 0 of h times, I still have negative 2 from that term. This would still have a negative 2x, and this would still have a negative h. And now I get that h to cancel, which again is the whole goal. Now I'm allowed to plug 0 in. So I'm really looking at the limit as h approaches 0 of negative 2x, negative 2x minus 2. I wrote those in different order, sorry about that, minus h. And now that I have gotten this h to cancel, now I can plug 0 in. And notice that I don't write the limit as h approaches 0 because I'm actually plugging 0 in. There's no h there, so I just get negative 2x. There's no h there, I just have negative 2. And then this would be minus 0, which won't change it. This is actually your difference quotient. Like I said, you'll get quite a bit of practice with that in section 3, as we'll spend basically 2 days doing this again. Alright, there is your homework help for section 12.2.